All right, so then to describe the solution regions, which would be all the angles where that graph is graphed below the x-axis, we could do interval notation or we could do inequality notation. So I'm going to practice with inequality notation because I feel like you guys are really good at interval, and inequality you might not be as good. And so if we're looking at the graph and we're reading it from left to right, what is the smallest angle that is in the solution region? Negative pi. So for inequality notation, you're going to start with negative pi. And then it's going to either be a less than or equal to. It's definitely going to be a less than symbol. But then to decide if we do the or equal to, you look here. So if it has an or equal to, we put it there. And then our variable here is x. And then less than or equal to 0. So you do the smaller one, less than x, less than bigger one. All right, and then we do that again for the other region. Now, if an endpoint of this big interval is part of your solution, just be careful. I noticed this not necessarily on our notes, but on some of the worksheets problems. Like this would be or equal to, but this wouldn't. Like it wouldn't include 2 pi. So just be careful. You can't include 2 pi in your answer if it's not included in the whole interval. You would just do less than, not less than or equal to. So there's lots of tiny little details you have to pay attention to every time. Okay, so it's easy to do it from the graph. Y'all could do that all day long. But we're going to need to be able also to do it from the algebraic expression. And so for example 2, we're going to give all the values between 0 and 2 pi. And in this case, we're not including 2 pi. Where the sine of theta is greater than the square root of 2 over 2. All right, so we're going to look at our unit circle. What angles have a sine that's equal to the square root of 2 over 2? Pi over 3 and, pi over 4, and there's one more, square root of 2 over 2. 5 pi over 4 is negative 3 pi over 4. So that's where you start. You find what angles have sine that's equal to that. And then that's the y coordinate. So the y values that are greater than that, would they be above it or would they be below it? The number line. Is it greater going to be above or below? So we would, on our unit circle, highlight all the places where the y is greater than that because it's above it in the coordinate plane. And then we're just going to describe our solutions. All right, so the answer is all of these angles that are between these two. And so we would start with the smaller one, which is pi over 4. And then because this has an or equal to bar, we're going to say less than or equal to, and then we're going to use the variable in the problem. The variable in the problem is theta. And then less than or equal to 3 pi over 4. Okay. All right, we're going to do some more. We're going to have to do our own little unit circle on these. And a little bit more work. So for example 3, we have f and g, and we want to know between 0 and 2 pi, or including 2 pi this time, when f is less than g. So we'll just take f, and we're going to set it less than g. And then we'll just solve that for cosine by subtracting 4 and dividing by 2. So I'm going to do just an X and Y axis. We're not going to draw the whole unit circle over here. There's just not room. It'll be kind of crazy. But looking at your unit circle or just out of your brain, what are the 2 angles on the unit circle whose cosine is -1/2? Yep. I didn't hear your second one. Are you still thinking? Yes. So cosine is going to be negative in the second and the third quadrant because that's where the x coordinates are negative. So, okay. Now we're thinking about x's now. So if you're thinking about x's on the number line, and we want to know where the x's are going to be less than this, is that going to be to the left or to the right? To the left. Less than is to the left. Maybe I'm asking that weird. I don't know. Am I asking that weird? A little bit? Okay. So that's going to be our solution region. All of these angles that fall in between 2 pi over 3 and 5 pi over 3. 4 pi over 3. And so the smaller one is going to be 2 pi over 3. Because I don't have the or equal to bar in our problem, it's just going to be less than. Our variable this time is x, less than 4 pi over 3. You guys feel okay? Can't tell. Okay, let's do another one. So for example 4, we have h and k this time, and we want to find when h is greater than k. All right, so we're going to get our cosines together by subtracting a cosine. If I subtract a cosine from 3 cosines, how many does it give it? 2 cosines. So 2 cosine of x greater than the square root of 3, and then I would divide by that 2. All right, so I'm going to think about my unit circle, and I want to know what angles on the unit circle are going to have a cosine that is the square root of 3 over 2. There's going to be 2 of them. Every time I ask this question, there's going to be 2. Yes. Nice job. All right, so we're either going to use these angles or we're going to use these angles. If it's greater than, is that going to be the x's that are to the left or to the right for greater? Right. All right, that's our solution region. But this one's a little tricky. Can we say that our solution region is pi over 6 and then less than x and then less than 11 pi over 6? We can't. That would be these. That's the exact opposite of what we want. So these are the angles we want, all of these here. What is the smallest angle there? 11 pi over 6 is not the smallest. It's not labeled. Exactly. 0. 0 is the smallest angle. Do we do or equal to? We do not. So I'm gonna do an angle from 0, or a region from 0 to pi over 6. Or then I need to describe this region. What's that going to be? Nope, that's going to be all of that. What did you say? 11 pi over 6 to 2 pi. Yes, 11 pi over 6 to 2 pi. All right, I know I'm making y'all think today, and we haven't even gotten to the ones that are kind of crazy. Okay, so look at those two. They're basically the same, but given your answer on example 4 is just a lot more challenging than example 3. Okay, so when we did this with polynomials and rational expressions, do you remember having to do the sign charts where we do a number line and we would do parentheses for all the factors and decide if we get positive or negative? We're going to have to do that with trig. And you can do it. It's just going to be difficult. But don't forget, you can do hard things. You all can do hard things. You just have to keep going. All right, so on these, I'm going to kind of like talk about the steps as we do the steps. So whenever it's one where you have like a sine squared and a sine, or a cosine squared and a cosine, we're not going to be able to just do the highlighted unit circle. We're going to have to do the number line. And so what we want to do first is find when the function equals 0. So we would start off and take 2 sine squared of theta plus sine of theta and set it equal to 0. And this is what we've done the last 2 days. So if you've been doing that and actually doing it and not copying somebody's, then you probably are going to be fine. So what would you do here? Take out a common factor, which in this case is going to be sine. And so I'm going to factor a sine out of each of those, which is going to leave me with 2 sine of theta plus 1. And then we set each of those equal to 0. I'm doing some steps because we don't have very much room. I'm doing like a bunch of steps at once. Okay, and then you can use your unit circle, or you can just try to remember. This is going to get a little more challenging to do without a unit circle in front of you, but you can do it. So we want to look at our unit circle, and we're looking everywhere, including 0 and including 2 pi. We want all those angles that the sine is 0, or all the angles where the y-coordinate is 0. So that's going to be 0, pi, and 2 pi. All right, and then we want all the angles whose sine is -1/2. So that's going to be 2 of them that the y-coordinate is -1/2. So if this was an equation, we would give those answers. But it's not. It's an inequality. So what we're going to do is we're going to draw a number line. Now, things that are different from when we did this with polynomials and rational is the number line just kept going in both directions. Our number line, because this is our interval, is going to stop at 0 and 2 pi. Right, and then we want to put a point at every one of these that we have, and it doesn't have to be spaced out correctly. It just needs to be in numerical order. So if I'm looking at these numbers, 0 obviously is first, and then it's going to be pi, and then 7 pi over 6, and then 11 pi over 6, and then 2 pi. I'm going to move it over just a tad bit more. All right, so what I'm going to do is I'm going to put it into the factors that we got right here. Now I'm going to write them again. You don't necessarily have to, but what I'm plugging them into is sine of theta times 2 sine of theta plus 1. So I have 2 factors, so I'm going to do 2 little parentheses in each region. All right, and so A lot of the time, you can just use an angle from your unit circle to make these decisions. Sometimes you're going to have to draw a new one, or at least draw it in your head. So if I want to pick an angle that's between 0 and pi, the best one to pick, in my opinion, between 0 and pi is going to be this one. Because if you pick this angle, you're only going to be plugging in like 0 and 1, which are super easy to plug in. The rest of them, you'll have to do some kind of fraction. So I'm going to use pi over 2. And so if I do the sine of pi over 2, is that going to be positive or negative? Positive. All right, and then if I do 2 times that sine and add 1 to it, is that going to be positive or negative? Anytime you add to a positive, it's going to be positive. There we go. Okay, and then the next one is a little more challenging. So now I want to pick an angle that's between 0 and 7 pi over 6. There's not a special angle that I have already that is between pi and 7 pi over 6. There's not one, but we can draw one. Let's say we have one right here. The y-coordinate here, you go down 1/2. So what would you guess we could say for the y-coordinate here? Yeah. So the sine is going to be the y-coordinate there. So whenever I find the sine of the theta I'm using, we're just going to use negative 1/4. So would the sine of that be positive or negative? Negative, because the sine is negative 1/4. All right, and then we said the sine is negative 1/4. We're going to do 2 times that sine plus 1. What is 2 times negative 1/4? Yes. If I add 1 to that, I'm not going to get positive or negative. Positive. So that's negative. Oh, I forgot to do something that was kind of important. Let's just pause for a second. Sorry. I need to go back in my numbers I got right here for my theta. I need to either label them with an open or a closed circle. What do you guys think it's going to be? If this was our original inequality, open or closed circles? Open. So if I don't have the or equal to, I don't include those in my answers. So I have 0, pi, 2 pi, 7 pi over 6, and 11 pi over 6. They're all open circles. Should have done that before, sorry. Okay, so we're going to pick back up. We're going to pick an angle that is between 7 pi over 6 and 11 pi over 6. So anything in between these two to be our theta, I would highly recommend this one, where for the sine, I'm just going to plug in negative 1. So the sine of 3 pi over 2 is a negative. And then if I do 2 times negative 1 plus 1, that's also going to be a negative, which is a All right, and then we're back to a similar situation when I have between 11 pi over 6 and 2 pi. I don't have a special angle already on my unit circle, but I can draw one. That's actually a reflection of this green one I just did, where the y is going to be negative 1/4. And so the exact same thing is going to happen again. So you could go through it again if you wanted to, but the exact same thing that we had right here is going to happen again because they both are going to have the same sign. All right, now I know that's a lot and we're not done, but we're close to being done with this problem. Okay, so what do we want? Do we want plus or do we want minus? Yes, because we want to know where this thing is less than 0. Less than 0 is negative. And so what I'm going to do is I'm going to highlight, I'm going to go ahead and use red. I'm going to highlight the negative regions. And then somewhere, I'm going to find room. I'm going to write what they are. I guess I'm going to write it above. So the answer to example 5, I'm going to put up here. We're going to go from pi less than, our variable is theta, less than 7 pi over 6, or 11 pi over 6 is less than theta is less than 2 pi. That's our answer. That's a lot. It uses all your skills pretty much. Okay, we're going to do one more, which is basically the same. The factoring is a little bit different. So how do you know when you can just factor out a common factor or when you have to do like factor it like a trinomial with the two sets of parentheses? Yeah. Pretty much if you have 3 terms, then you're going to do it like a trinomial. And there is no common factor. They don't all have anything in common. So I'm going to set it equal to 0 and factor it at the same time. So I know what I put here and here. It needs to be 2 cosine of theta. So what do y'all think? One of them's going to be cosine of theta. What's the other one going to be? 2 cosine of theta. Good job. It doesn't matter. And then I know my signs are going to be different because I want a negative 1. And the only way to get negative 1 is a positive 1 times a negative 1. So I know these are going to be 1s. And in the middle, I want to get a positive cosine. So which one needs to be positive? It's a little tricky. It needs to be the one that's going to get multiplied by the 2. So it's this one. Now, if you had done the other order, obviously it would switch. All right, so we are going to want to use our unit circle and find all the angles whose cosine is negative 1. That's probably just 1, right? Yeah, it's just pi. And all the angles whose cosine is 1/2. That's going to be 2 of them. Hang in there. Y'all are doing great. All right, so on our unit circle, on our number line, we're going to go from 0 to 2 pi. And I'm going to put the angles in that I just found in numerical order. So it's going to be pi over 3, pi, 5 pi over 3. All right, and so this time, bless you, because I do have the or equal to, I am going to make those dark circles. All right, and this is what I'm plugging them into, those 2 factors. So first I want to pick an angle that's between 0 and pi over 3. Let me erase some of this. Okay, between 0 and pi over 3. So we have 2 special angles. Either one's a good option. Do you guys have a preference? Anybody? All right, let's just go ahead and let's use pi over 6. All right, so we are doing the cosine. So the cosine of pi over 6 is the square root of 3 over 2. If I add 1 to that, am I going to get a positive or a negative? Definitely a positive. When you add to a positive, you get a positive. All right. And then if I multiply that by 2, it basically cancels out this, and I get the square root of 3 minus 1. Is that going to be a positive or a negative? Yeah. So the square root of 1 is 1. So square root of 3 is bigger than that. So it's definitely going to be a positive. It's okay. It's a lot. It's a lot. Okay, so now in this other region, I want to pick an angle between pi over 3 and pi. Oh, I did not mean to use that. That's okay. So let's use pi over 2. For the cosine, I'm going to use 0. So if I do 0 plus 1, it's a positive. If I do 0 minus 1, it's negative. So when I multiply those, I get a negative. Okay, between, pi and 5 pi over 3. That's great. I can go ahead and use this one. My cosine is going to be 0 again. So the same thing is going to happen. Okay. And then if I use 11 pi over 6, the same thing is going to happen that whenever I used pi over 6, because they have the same cosine. And so I can just copy this guy if I wanted to, or you could go through it again. It's up to you. But that's going to be a positive. All right, are we looking for positives or negatives on this one? We're looking for positives. So my endpoints do have or equal to, so I will connect them that way. This is super tricky. Anything that is dark colored right now on this number line is a solution. So obviously, 0 less than or equal to theta less than or equal to pi over 3. Or do you see something else that's dark and colored that's not your other region? Pi. Pi is a solution just by itself. Because if I put that in for my theta, I get 0, and 0 is greater than or equal to 0. So that's a little tricky there. And then I'm going to go from 5 pi over 3 to 2 pi.